Hello, this is AP Classroom Unit 5 Free Response Question Set B, number 1. And there is no calculator allowed for this question. And basic information, this problem actually starts right here at this graph. So let's start taking a look. We have this graph of G. The graph of a continuous function g is shown above for x between -3 and 3. The function is twice differentiable, which means that you can take the derivative twice and it exists, except at x equals 0. So there's a problem going on at x equals 0 somewhere along the line. F is another function where f of 0 is equal to -1, and f prime is this, x squared minus 5/4 times e to the x. We don't have the actual equation for f. We do have the equation for the derivative. So part A says find the x coordinate of each critical point of f. So we know we're dealing with this. Classify each critical point as the location of a relative minimum, a relative maximum, or neither, and justify your answers. Clearly not enough room here to work, so I'm going to come over here. So, let's see, part A. Critical value of point f. So critical numbers are going to occur when the derivative is equal to 0, undefined, or does not exist. We know f prime is x squared minus 5/4 times e to the x. And again, critical numbers occur when f prime is equal to 0, f prime undefined, or f prime does not exist. And there are none here and none here, because you can substitute in any number for x that you want and get an answer out of here. For f prime equal to 0, either x squared minus 5/4 equals 0 or e to the x equals 0. That can't happen. E raised to a number can never equal 0. Solving here, x squared is 5/4, so x is plus or minus the square root of 5/2. There's your critical numbers right there. Now, it says classify each critical point as the location of a relative minimum, relative maximum, or neither. So, we need to do a sign analysis here. So let's set up a number line for f prime. Make sure you label your number line. And we have negative square root 5/2 and positive square root 5/2. All right. We need to evaluate f prime at these sections. If you don't have an idea what this decimal value is, that's fine. Choose something like you know for sure is way far away, like -100, something like that. So if we put -100 in here, that's going to be 100 squared, 10,000, minus 5/4, that's positive. This is positive, so overall positive. Something in here would be 0. This is 0 squared minus 5/4. That one's negative. E to the 0 is 1. This is positive. So we have a negative times a positive. Overall negative. Again, something way out here. If you're not sure what this decimal is, choose 100. And we're going to get the same thing here. This piece is going to be positive. This tells us that f of x then is increasing, decreasing, increasing, which means that this produces a relative max, and this, changing from decreasing to increasing, produces a relative min. All right, so now we've got all our work, but we need to write out your answer for the justify your answer. So we're going to say there are critical numbers for f of x at x equals plus or minus square root 5/2. And there is a relative maximum at x equals negative square root 5 over 2, because f prime of x is positive, so greater than 0, for x less than negative square root 5 over 2, and f prime of x is less than 0 for negative square root 5 over 2 less than x less than square root 5 over 2. This means that f of x changes from increasing to decreasing at x equals negative square root 5 over 2. That gives us the relative max. Now we're just going to write the words for the relative minimum. There is a relative minimum at x equals positive square root 5 over 2 because f prime of x is less than 0 for negative square root 5 over 2 less than x less than square root 5 over 2, and f prime of x is greater than 0 for x greater than square root 5 over 2. This means that f of x changes from decreasing to increasing at x equals square root 5 over 2. Oops, off the screen. Sorry. I get so involved in writing that I forget to look at my computer to see where it's at. Sorry about that. Okay? All right. There's part A. Oh, and there's my husband's cell phone, and it's early in the morning, and he is still sleeping, so we're just going to wait until it stops ringing. All right. Part B says, find the values at which find all values of x at which the graph of f has a point of inflection. Give reasons for your answers. Okay. Points of inflection come off the second derivative. So, f prime, I'm just going to write it here, so this is part B. So I have it all over the place again, and I have it right in front of me, not all over the place, but right in front of me. There's f prime. Now we need to do a derivative to find out about f double prime. So f double prime of x, we have a product rule going on here. First, x squared minus 5/4 times the derivative of the second, e to the x, plus the second, e to the x, times the derivative of the first, which is 2x. Let's see, I am going to go ahead and factor in e to the x here. This would be x squared minus 5/4 plus a 2x. I'm going to do some algebraic rearranging here. X squared plus 2x minus 5/4. Now, for points of inflection, I know that I'm going to have to figure out where f double prime is equal to 0, undefined, or does not exist. It's going to be very difficult to do with this fraction here. So what I'm going to do is actually factor out a 1/4 out of here. So e to the x times a 1/4. Okay, 1/4 times what right here would give us x squared. That's a 4x squared. And then 1/4 times what here would give us that 2x. It's an 8x. And then a minus 5. What that does for us is it makes it easier to factor this piece down here. That 4x squared minus the 8x minus 5 does factor. 2x. multiply by 5, it's got to be a 5 and a 1. Plus 5 minus 1. That'll give us a minus 2x here and a plus 10x there, which is that 8x. And, now we're all factored, so we're good to go. At this point, then, we can figure out where is f double prime equal to 0 on it does not exist. None here, none here. And here, this e to the x over 4, that can never equal 0. This piece, that's going to give us that x is a half, and this piece, negative 5 over 2. All right, sign analysis now. Make sure you identify the name of your number line. Negative 5 over 2, and over here, a half. All right, substituting back in, all we're interested in is the sign of f double prime, whether it's positive or negative. This piece right here, e to the x over 4, will always be positive, so I don't need to deal with that one. Choose something smaller than negative 2.5. Let's go negative 3. This would be negative 6 minus 1. This is negative. And negative 6 plus 5, this is negative. So we have negative times a negative is positive. And then in here, how about a 0? It's negative times positive, which is negative. And over here, something bigger than a half, say 1. Positive, positive, this is positive. All right, so now, right here, our second derivative is changing sign. That means that f is concave up here, concave down, concave up. So we definitely have a change in concavity. The other thing we need to talk about is a tangent line. So does f prime exist at negative 5/2 and a half? So look back up here at f prime. Can you substitute in a half and get an answer? Absolutely. Can you substitute in a negative 5/2 and get an answer? Absolutely. So that first derivative does exist, so there is a tangent line there. A lot of talking going on. Let's write this out so we have a complete and nice justified answer. There are points of inflection. At x equals negative 5/2 and positive 1/2. Sorry, I had them backwards here. Negative 5/2 and x equals positive 1/2. Because there, let's see, f double prime of x changes sign at these values, and f prime of negative 5/2 exists. Oh, let's write those. So f prime at negative 5/2 and f prime at a half both exist. So there is a tangent line at each point. And that's it. If you wanted to put another sentence in there that, or a phrase in there that says, since f prime changes sign, that means that f is changing from concave up to concave down, that's fine, but it's perfectly acceptable just to say this. All right. Moving on to part C. C I have to do on here because it asks us some information about that chart. So we're just going to fill in that chart. All right, fill in the missing entries in the table below. Describe the behavior of G prime and G double prime or to describe the behavior of G prime and G double prime on the interval from -3 to 3. Indicate positive or negative. Give reasons for your answers. Okay, so this is the graph of G. G prime is slopes of the graph of G. So when we go to fill this in, between -3 and 0, slopes here are positive. Okay, and how about between 0 and 3? Slopes are positive. Now again, you're reading the graph of G, not the graph of G prime. So you're reading the graph of the original function. G double prime talks about concavity of G. So look at G and let's talk about concavity. From -3 to 0, this graph is concave up, which means G double prime is positive. And for x between 0 and 3, this graph is concave down, so G double prime is negative. Okay? All right, so fill in the missing entries. Got that. Indicate positive or negative. Done. Now, give reasons for your answers. So for this right here, for G prime is positive on both intervals because G is increasing. G prime is positive on both intervals because G is increasing. Okay, for G double prime, this row right here, oh, it froze, darn it! Ugh. Okay, video 1 of 2, I'll be back.